Visible to the naked eye, only 1,500 light-years from Earth, the Great Orion Nebula has been known and revered since ancient times. A popular target of Hubble, researchers have now identified 42 new disks within it that could be the beginnings of new planetary systems like our own. Within the awe-inspiring gaseous folds of Orion, researchers, using data from the Wide Field Channel on Hubble's Advanced Camera for Surveys, have identified two different types of disks. The ones that lie close to the brightest star in the cluster, Theta 1 Orionis C, and those farther away from it. The star affects the nearby disks by heating up the gas within them, causing them to shine brightly. The excited material produces many glowing cusps, which all face the bright star and are thus randomly oriented within the nebula.
We have never seen them directly, yet we know they are there, lurking within dense star clusters, or wandering the dust lanes of the galaxy, where they prey on stars or swallow planets whole. Our Milky Way may harbor millions of these black holes, the ultra-dense remnants of dead stars. But now, in the universe far beyond,
theory of planetary motion. He said that it is the Sun which is the center of the solar system, and all the planets as well as the Earth revolve around the Sun. Later on, a German scientist by the name of Johannes Kepler in 1609 wrote in his book Astronomia Nova that not only do the planets, including the Earth, revolve around the Sun, but they also rotate about their own axis. 25 years ago, we were taught in school that planets, including the Earth, not only revolve around the Sun, but they also rotate about their own axis. The whole solar system in the galaxy revolved around the Sun, and in this context, the Sun was stationary, as it did not rotate about its own axis. There is a verse in the glorious Quran in Surah Al-Anbiya, chapter 21, verse 33, which says, "It is Allah who created the night and the day, the sun and the moon, each one in its orbit."
Are balanced. It still happens today in nearly exactly the same way it happened more than 5,000 years ago when the temple was made. On equinox days, the central corridor is lit all the way to the back of the temple. Stones were deliberately arranged inside the portal to restrict the entrance of sunrise in a particular pattern at other times of the year. On the summer solstice, when the sun rises higher in the sky in the northern hemisphere and the hours of daylight are longest, the sunrise highlights the far edge of a standing stone inside the temple. On the shortest day of the year, the winter solstice, the light falls on a matching stone on the other side of the corridor. A functioning prehistoric timepiece, every morning from one year to the next could be marked by sunrise somewhere across this configuration of stones.